super excited to be here in Ethereal. So the topic of this talk is the two-tiered consensus. Blockchain architecture to bridge the Dapp app gap, and you're probably asking yourself what exactly is this gap, and I promise you I'm going to define it in this talk. So before we dive in, I want to introduce myself. So my name is Tal. I'm the co-founder of Orbs.com. Orbs is a public blockchain, a permissionless blockchain infrastructure for app developers. It's also coming out of Israel. It's probably one of the largest blockchain projects coming out of Israel. In my previous positions, I was head of mobile engineering in Wix.com. Wix.com is a very successful Israeli company, not blockchain related, that is a world leader in cloud platform for the web and web developers. And that's where I really got to learn and understand the enterprise. Wix has thousands of employees, 150 million users, and to see an operation that works at that scale was very fascinating. I'm also a very passionate open source contributor. I'm a contributor to one of the top projects on GitHub, which is React by Facebook. If you Google my name, you'll see me speaking in various open source conferences, and some of the libraries that I've created have been used in some popular places. For example, the latest app of the Olympics used a library of mine. Another position that I've held is I tried to take the first billion-dollar consumer company into blockchain. This was also a fascinating experience. So the question that we'll discuss in this talk is this, and I think this is a very important question for the industry in general. Will enterprises cross the chasm towards permissionless infrastructure? So the enterprise is interested in blockchain. We know about that. We see a lot of engagement. But we're in Ethereal. Ethereal, we have the passion of permissionlessness, the passion of decentralization. And it's no secret that enterprises gravitate towards private and permission solutions. Now, when will we see the enterprises using the disruption, the permissionless aspect? So before we answer this question, I want to start with several definitions, just to make sure that we're all on the same page. So if you look at blockchain infrastructure, you can roughly separate it between two kinds, permissioned and permissionless. What is permissioned blockchain infrastructure? We call this the private blockchain. The validators are always from a select group that somebody chose. If you want to be a validator, you have to ask for permission. The consensus mechanism used in these blockchains are proof of authority. There is a centralized point of authority in them. And this also means that you have trust. You have to rely on trust, some degree of trust in these systems, because the end users usually cannot audit and know what happens inside, because in order to do so, they would have to participate in the consensus, and they usually don't have permission to do so. Now, are these systems new? Like, did we have to wait for Bitcoin for these systems to be created? And I would say no. We had these technologies before. These are databases used by multiple companies to collaborate. So I would say this is not part of the Bitcoin disruption. A good example of such infrastructure is Hyperledger, a very popular solution. On the other hand, we have permissionless infrastructure, what we call the public blockchain, the mainnet. Here, what's special about them is that anyone can become a validator. You can participate. It's fair play for everyone. The consensus used in these systems is usually proof of work, and now moving more and more towards proof of stake, for example, Ethereum. And the special thing here is that there's no trust. These systems are trustless. And they can be trustless with end users by the fact that end users can fully audit what happens inside. You can participate in the consensus. You can check everything that goes on. And if you ask me, these systems are new. We didn't have them before the Bitcoin age. This is the main disruption of the Bitcoin age. What happened in the last 10 years? What is the main thing that this entire field created? I would say that it is permissionlessness. The human race did not have a way to create a permissionless list of somebody without having one of us choose the list. This is something brand new, and we're still grasping what can we do with it. A good example of such infrastructure is Ethereum, the mainnet, of course. We talked about infrastructure. Let's talk about who's using the infrastructure. Let's talk about the customers. And if you talk about customers, I usually like to segment the market into two different and mutually exclusive parts, enterprises and DAOs. So let's define each of them. Enterprises, and when enterprises build an application, we call it an app. They are just regular for-profit businesses. This is the common business model on Earth. 99.99999% of the businesses on Earth operate under this business model. They have centralized governance, the regular plain old thing. You have a CEO and shareholders, and they choose what the company does. What's special about them is that they don't need a token economy. They don't want a token economy. A token economy just disturbs their inner working. Usually in crypto conferences, when we say enterprise, we don't refer to the size of the company. Outside the crypto world, enterprises mean large companies. But just for the sake of clarity, even a startup of 10 people, if it's a for-profit company with no token economy, we will consider as an enterprise. Examples of these companies. For example, if your product is ride-sharing, Uber and Lyft. On the other side, we have a very different type of customer. DAOs, decentralized autonomous organizations. And when they're building apps, we don't call them apps, we call them dapps, decentralized applications. So these decentralized organizations are very disruptive. They have a new business model that no one has seen before, and they emerged in the blockchain age. They didn't exist before Bitcoin. I think Bitcoin is the first good example of a DAO. What's special about them is that their governance model is decentralized, and that's weird. In order to band the community together behind a certain goal, you need a way, and this way is using an incentive model. And the best way, the most practical way to implement an incentives model is using a token and a token economy. This is also a way to differentiate between the two. If you want to know if you're dealing with a DAO, look for the token economy. There is a token economy, it's a DAO. There is no token economy, it's a regular enterprise. That's my definition. Examples of these companies, we talked about ride-sharing, so I Googled decentralized ride-sharing. I saw some examples, Eva, Dav, Quicksilver, I don't know if they exist anymore, but they definitely tried to launch in the past 2 years, and they're trying to solve the problem of ride-sharing in a completely decentralized way. And this brings us to the interesting analysis of the industry. Let's take all of the solutions out there, and let's plot them and segment the market according to these definitions that we made. So if we look on the horizontal axis, you see the infrastructure. On the right side, you see permissionless infrastructure. On the left side, you see permission infrastructure. And if you look at the vertical axis, you would see the customers. On the top, you would see those infrastructures that are targeting enterprises, for-profit businesses, or apps. And on the bottom, you would see those targeting primarily DAOs, or decentralized applications. And the market is very much segmented into two extremes, and I call these extremes the blockchain economy. All the permissionless infrastructures, projects like Ethereum, Loom, Polkadot, Cosmos, are all primarily designed to tailor DAOs. And the only infrastructures that are primarily designed to target the enterprise are permissioned, and this is super interesting. What this graph shows us, this segmentation, it shows us a big opportunity. And the opportunity is right here, in this segment. Now, why is this segment so interesting? This is the sweet spot where the mass market can meet the disruption in trust. So those are big words, let's go over them. Now, this is where I'm super passionate. Why? Because I'm passionate about the disruption, about the technology. I want the disruption in trust by permissionlessness, but I also want to build products that meet mass market and have mass adoption. This is exactly what Orbs try to do. We try to play in this space. And this is a space that not many groups or projects try to play in. And why is this the sweet spot? Because the disruption is on the right side. Permissionless infrastructure is where the disruption of the blockchain era exists. That's where trust changes. But if you look at the market, where do you have a lot of customers? The market size is at the top. You don't have a lot of DAOs, you don't have a lot of dapps out there. Dapps may be coming, but it could take many, many years. If you want to address an existing market, you need to address them. So to figure out how to build a permissionless infrastructure for their needs is a bit of a difficulty, and that's exactly what we're trying to do. So I promised to talk about architecture. I want to show you how you can design architectures. If you define the challenge that you want to solve this way, it causes you to design architectures that are primarily designed for this problem, and you end up with something a little bit different. So in order to discuss this, let's talk a little bit about blockchain consensus. How does blockchain consensus work? So the process is very, very simple. You have a bunch of nodes that are operating the network. So one of these nodes is going to propose a block. They're going to propagate the block inside the network, and a group of other nodes are going to verify it. Others will verify, and if the verification process succeeds, it passes consensus, and the block is added to the chain. Now, almost all blockchains work this way. It doesn't matter if it's proof of work or stake, and it doesn't matter if it's permissionless or permissioned. Bitcoin or Ethereum, for example, proof of work, the node that proposes a block is selected according to the first node that solved the cryptographic challenge. And then all the other nodes just check that the work is indeed correct, and they verify that the block is according to the protocol. Proof of stake works exactly the same way. Let's take a look at EOS, for example, a production proof of stake system. They have 21 nodes. the node that proposes a block is just chosen by round robin, one of the 21, and the other 20 will verify it. Okay, Orbs uses a different mechanism. We used randomized committees, but this is not very different from even how Hyperledger does it. Now, the interesting question to ask in blockchain is all about the governance aspect of things. Who makes the decision and who chooses the nodes? So the interesting question that I will ask is, can the app choose the identity of these nodes? And it turns out that this is the most interesting question to ask, because this will exactly split the market between the two types of infrastructures that we've seen. So let's take, for example, a public blockchain like Ethereum. Can the app choose the nodes? Of course not. If you're writing a Dapp on Ethereum, you have no say on which miners run your app, run your Dapp. So of course not. And if Walmart is implementing Hyperledger for a supply chain use case, for example, in a private blockchain, of course that Walmart is going to choose the identities of the nodes. So if we talk about nodes, in a public blockchain, nodes are selected by the network, usually using some sort of incentive system. And on the private blockchain, just the app selects them. It's their prerogative. Now comes the interesting part. If we want to think about things differently, and we want to solve the weird problem that we addressed earlier, what happens if we separate the nodes into two distinct groups? And we'll just label them differently. So remember the steps about the consensus that we've discussed? Let's call the nodes that propose a block producers, and let's call the nodes that verify the blocks validators. Let's run through the process, and the process is exactly the same, just with different labels. One of the block producers will now propose a block, and then they will send the block to a different group, to the group of validators, and then the rest of the validators will verify it. If the block is okay, it will be added to chain. We didn't change anything except apply labels, but now the two groups can have different kinds of nodes. And this opens up a whole interesting range of possibilities. So now when we apply these two labels and we look on a public blockchain like Ethereum, of course, both the block producers and validators are the same nodes, and they're always selected by the network. On a private blockchain like Hyperledger, both of these groups are selected by the app. It's the same group. But now comes the aha moment. What if we do this interesting thing? What if we have a hybrid architecture when one group is selected by the network and the other group is selected by the app? Now this opens up, it has some very, very, very interesting implications. This is exactly what we're doing in Orbs. So the validators must be selected by the network. The app has no say on which validators go over the blocks, but we do allow block producers to choose their own servers. Now remember the sweet spot? I want to show you how this architecture can bring us there. We define the sweet spot as the point where the mass market meets the disruption in trust. So if we talk about, so let's define these terms a little bit more clearly. What is this disruption in trust exactly? Now, if you ask 20 industry experts, what is the disruption in trust in blockchain, you would get 20 different answers. Okay, so this is a very difficult question to answer objectively. But I will give you my subjective truth. I see the disruption in trust as guarantees that blockchain can give to users, to end users who are not participating in running the protocol or operating the network. So some of these guarantees, for example, is that the apps running on top of this blockchain behave according to some contract. We usually call this contract a smart contract. It's represented by lines of code. These lines of code sit on the blockchain itself. So instead of relying on lawyers, code is law. In addition, users can fully audit the app. How can they do that? They have the code, they have all the data. The data is available on chain, they can feed the data to the code and see that they get the same result. So this is perfectly auditable, they have a strong guarantee both on the data and the algorithm. Another interesting guarantee that blockchain can disrupt is the fact that you can fork the app if you're unhappy. Let's assume that you see an app on the blockchain and you want to add a feature, but the app developer does not agree with you. They don't want to add the feature by themselves. Okay, you can add it. You have access to the code. You have access to the data. You can create a fork of the app that can fully compete with the existing version of the app. There is no captive audience. Then you can go to the community, pitch your version, and if your version is good, according to the consensus, to the community, they will just move over. So it's all fair play. And the last guarantee, I think, has to do with governance. And governance should always be guaranteed, because if you can change the rules without explaining how you do so, then all of the other guarantees are pretty much meaningless. So what we expect apps in the blockchain age to do is to define the way that their own governance applies, how they can change their code, for example. Now, if we defined the disruption in trust this way, according to these guarantees, it turns out that you can reach the same level of disruption only by having validators selected by the network. Now let's look at Ethereum as a public blockchain. Why is the fact that the validators are selected by the network creates a disruption? The reason is that the app cannot vouch for itself. It's meaningless. The centralized approach that you see with permissioned blockchains or centralized systems is that the app always vouches for itself. It says, I'm running according to contract, and you know what, just trust me that I'm doing that. Only with a blockchain where the nodes are somebody else, and it's trustless, and it's governed by an unbiased, provably unbiased incentive system, you get the disruption, you don't vouch for yourself, the incentive system vouches for you. And you can reach the same level just by having the validators coming from an external pool. So that's enough. And this opens up the ability to make block producers selected by the app. And this is a degree of flexibility that will increase adoption. We can see that private blockchains like Hyperledger are using this approach to make themselves more applicable for enterprises or for-profit businesses. Why is that the fact? Why is that so? So in order to unlock the mass market and bring enterprise adoption, giving the freedom for these enterprises, these centralized entities, to choose their own block producers and to run on their own servers, it gives the app the control that they're missing. For example, an app can control its own servers. Imagine that you're going to Uber, and you tell Uber, go and run on a blockchain. If they have no idea of the identities of the nodes that are running their application, they're going to be afraid. It's going to be very, very different from what they're used to. And this control, it has also practical implications. It's not just irrational fear. For example, let's talk about a security vulnerability. On Ethereum, we had the DAO bug. When the DAO bug happened on one of the apps running on-chain, on the mainnet, the community has decided to roll back history to fix this vulnerability. Now imagine that Uber's app was also running on-chain. They would be out of control. They would not be in control of their own history, and their own history would be rolled back. If you tell Uber, are you willing to live in this world where you have no control over basic things, such as how history behaves, they would say, no way. We don't allow that. We will not adopt a solution that does not give us this control. Let's talk about security. In the blockchain industry, we like to feel that blockchain is much more secure than anything else. But imagine that you're going to the CTO of Uber, and you're telling them, you're pitching security, telling them, hey, do you have a security problem? I have a technology that is much more secure than what you're used to. And they're going to say, no, we don't have a security problem. Uber is very much confident in the level of security that they currently have. The entire world works with centralized security. They have their own admins, and it's okay. We don't need to fix a problem that does not exist. It's even worse. If you go into Uber and you tell them run on a permissionless, incentive-based infrastructure, they would say, we don't trust your incentives. What happens if the market crashes? We want to feel safe with our apps, and we prefer to put our trust in our admins. So here, if Uber can run their own servers, their own block producers, they're in charge of their own security. Much easier problem for adoption. Costs. If you're talking about adoption of for-profit businesses, costs are paramount. Why? Because these businesses operate for revenue. You can't just create economies and hope that they work out eventually. It has to make money from day one. And this approach can actually save a lot of costs. Why? Because block producers are the expensive part to run, and by having the app control its own block producers, it could just be centralized. They can have the same number of servers that they currently have, and the cost would be exactly the same. What about the validators? It turns out that to run a validator is much, much cheaper. Why? Because you can have if all the nodes have to do is just validate, the problem is much simpler. You can have, for example, stateless validation, which is much more cheaper to execute. Another thing that this sets right with enterprise, it defines the value proposition correctly. Because if you go to the enterprise and you try to pitch the value proposition of blockchain as decentralization, you're going to have a problem. Enterprises, for-profit businesses, don't see value in decentralization. Decentralization just makes them go away. Decentralization doesn't bring them more money. But guarantees, when we talk about the guarantees to users and creating bigger ecosystems with more trust for their users, now this is a value proposition that they can relate to. So we covered the basic architecture. Now let's make several observations that stem from this architecture. The first observation I want to make is kind of like a domino effect. When you make this architecture choice, there are other architecture choices that you must make as well. So let's go over one of them. And this is isolation between apps. This is something that you have to solve. So let's imagine that we have this architecture running. So we said that the validators are chosen by the network. So we have a shared network of validators on the bottom that is common to all apps running on the network. But we said that the apps can choose their own block producers. So here we have two examples of apps, and each of these apps has chosen different block producers. For example, Uber chosen its block producers, its own servers, and Lyft chosen their block producers. Or it could be Walmart, for example. Now, try to apply this architecture on a single chain like Ethereum. The blocks signed by the first app are going to be different blocks with different signatures than the blocks signed by the second app. If you're going to try to put both blocks on the same chain, you're going to run into difficulty. Therefore, the more natural approach is to actually put the blocks on two different chains. And this is exactly what we did. So the architecture that we opted for is called virtual chains. And virtual chains is a different concept which relates to what we're trying to solve very closely. The idea behind virtual chains is that you don't have a single chain for the mainnet, but you have multiple parallel chains. You have a chain per virtual chain. And every validator in the network, remember we had a shared pool of validators, every validator runs all of these chains in parallel and participates in all virtual chains. So basically what you get is a shared physical infrastructure. This is the idea behind virtualization. Just like Amazon has or VLANs have, you have shared physical infrastructure and you have the illusion of isolation running on top. This is exactly what you get here. So instead of having one chain of blocks, you have multiple. And what this means is that you have multiple instances of the consensus algorithm that are actually running in parallel. This is a gateway to speed and so forth. One of the things that we should be very careful when we're proposing sharding techniques, such as this one, is that we don't by accident shard security. Let's say that the security in the network, it could be proportional to the staking in the network, for example, and you have 10 apps running this way. You don't want each of the app to get 1/10 of the security. But if you think about this model closely, you see that this pitfall does not happen here. The security here is shared. Why? Every single app enjoys the benefit of all the other validators in the entire staking of the network. Why? Because every validator runs all virtual chains, and we evaluate the performance of every validator according to all virtual chains. So if a validator just abuses a single virtual chain, it will be penalized for all of them. So the security is combined, which is a great thing. The main benefit that we get out of this architecture is independent app governance. And independent app governance is crucial for implementing the architecture we just talked about. Now, app governance is something important. Think about the Bitcoin app. Look at how many governance problems they had just by discussing the block size. So naturally, different apps will have different needs and different requirements. So when you have separate consensus processes running in parallel for each app on their own virtual chain, every app is free to make this design decision for itself. They will not fight and fork and argue. So this works well for consensus params like block rate. Every app can choose its own according to its needs. But this actually solves the much greater governance problem that we've discussed. Think about security vulnerabilities. Think about the DAO bug. And this works both ways. Both, you have a security vulnerability in one app, you don't want to impact other apps if the network decides to fix it. But also think about the opposite. What happened with the parity bug? In the parity bug, we had a vulnerability that cost a lot of money, but the majority of apps did not want to fix it. So you want this isolation in both ways, so the communities for each app can make the separate decision for that app. So this architecture scales much nicely to apps created by different entities that have different interests in mind. Another great benefit out of this architecture is infinite horizontal scalability, because this form of separation is actually an inherent form of sharding. Every app runs on its own dedicated resources. You add more apps, and you don't have limited capacity anymore. And now if you go to Uber and you try to pitch a solution, this is crucial as well. Think about what happens when you have limited capacity. On Ethereum, where the capacity is limited, and you suddenly have a very popular app like CryptoKitties that is popular for a week. If this happens, if the capacity is limited, everything is going to get much, much slower to all the other apps. How can Uber operate under this? Like, they don't have any performance guarantees, and they don't have cost guarantees. Like, okay, if they want the performance, just pay more fees. Trying to tell Uber CFO to plan budgets, a yearly budget for cloud, using this approach. This works very poorly. If you have virtual chains, you don't have this problem. It eliminates the problem altogether because you pay for the resources you consume and you get an SLA. The performance that you get is guaranteed no matter how many other apps are running on the network. This also solves the diseconomy of scale that we see in blockchains with limited capacity. You know, infrastructure is supposed to get cheaper as more people use it, not more expensive. Think about it. I want to make another observation, this time about security. The architecture that we're proposing, you know, this two-tiered consensus, is it more secure or less secure than the traditional approaches that you're familiar with? So security is difficult to quantify, but we can quantify it using stake. We said that we use proof of stake. Usually the amount of value that is staked is proportional to the amount of security in the network. More stake, more security. So under this architecture, would you have to have the same amount of stake, more or less? So let's analyze. We said that the app is free to choose its own block producers, and we said that the network validators have to come from the shared validator pool that is chosen by the incentive system using proof of stake. So we have two groups, two different groups of nodes, app block producers on the left and the shared network validators on the right. Now let's analyze some attack vectors. Let's assume that the validators are compromised. How could this happen? This could happen if the incentive system gets broken. With staking, for example, somebody buys a lot of stake to manipulate the network. With work, this could happen if somebody does a 51% attack by mining very aggressively. So if the incentive system is compromised, what happens in this model? Well, only the validators have been compromised. The only thing that validators can do is just sign blocks. They don't produce the blocks. They don't choose which transactions go inside the blocks. They can't manipulate the blocks. So they can just avoid signing. What we did is we took a problem that was a safety problem and we changed it into a liveness problem, which is a great thing to do. Now let's analyze an attack vector from the other side. Let's imagine that we have the servers, Uber's servers compromised. We said that the left side, the block producers are running on the app's own servers. So what happens if an admin in Uber goes rogue and the servers are compromised? This could happen. Then again, if this happens, we have the network validators, and they have not been compromised. Why? Because the admin in Uber does not have access to them. They're owned by different companies, different entities, and multiple different entities. You have to hack each and every one of them in order to have the same degree of attack. So they could protect the users and not sign the corrupt blocks due to this compromise. So once again, we took a problem of safety and we changed it into a problem of liveness. Now taking safety problems and turning them into liveness problems is great. Why? Because it reduces the incentive to attack. An attacker has much less to gain. They cannot steal anything. They can just deny service. And when you don't have much to gain, you won't attack. And this is great. Now, we talked about quantification. We don't want to keep security in the philosophical realm. And this has serious implications about cost. Why? Because the staking burdens under these architectures is much lower. You don't need as much stake in order to reach the same level of security. And if you don't need as much stake, then the stake would not translate into higher fees for the apps running on side. So there are no free meals. Eventually somebody has to pay these costs. And these costs translate to higher fees for applications. If the staking burden is lower, these networks are easier to adopt because they're just cheaper to run. Now let's make the last observation before we finish this talk. And that is that this model is actually very future-proof. You know, many of us are dreamers. We're dreaming about dapps. You know, it's obvious that dapps don't exist today, but what would happen if dapps would emerge 20 years from now and this business model would become very popular? Is this architecture future-proof? Could an app turn into a dapp by making a governance decision? And it turns out that yes, the architecture is very flexible, and it can even run pure dapps. Let me show you how. So we said that the degree of flexibility that we've added is that the app can choose its own block producers. So the natural choice for an app like Uber is to just choose a permissioned list of block producers, choose its own servers. This is what most enterprises would do today. This is the classic model, a fixed control list. This is what we've analyzed so far. But the app is free to choose whatever list of block producers it wants. Let's say that in some years, the app decides to become a DAO, and it wants to disrupt itself. Okay, this could happen. So the app can make a governance decision and change the block producers. They're free to select them, and just take the block producers to be the same group as the network validators. They would rely on the network's incentive model to create a permissionless list of block producers. What do you get when you make this decision? You get a pure DApp. This is very equivalent to running on Ethereum. Okay, so this model could accommodate pure dapps as well. This is pretty cool. But this opens up a third possibility that it's, in my eyes, the interesting one to discuss with people fascinated with crypto. And that is, you can also make the decision to choose the block producers to be permissionless, but don't use the network's incentive model, use your own. So think about a decentralized ride-sharing app like the ones we've shown. So many of the dapps, they all have their own economies, they have their own tokens. The staking that can be done, does it happen with the infrastructure token, or does it happen with the app's own token? In all of the cases that we see today in the wild, it's always with the infrastructure token. The apps rely on the incentive model of the infrastructure. And this makes sense sometimes, but sometimes it doesn't. In many cases, apps would want to rely on their own incentive system. They have a token economy, they can use staking to choose their own block producers. And this is pretty exciting. What this can do, it's a very interesting solution to the stake disproportion of secondary tokens. In the Dapp hype, I talked to many dapps out there just to judge what the customers want. And so many dapps out there didn't really understand, that proof of stake doesn't use their token. I had the conversation with Dapp developers, and they were creating their own tokens, and I asked them, is the proof of stake, is the staking, does it happen with your own token? And they would say, yes, of course, that's what they expected, some of them. And I think this is convoluted and incorrect. It uses the infrastructure. So how does it relate to the app? And the worth of the stake in both edge conditions doesn't have to be proportional. It doesn't make sense for the infrastructure to be worth more than all combined apps that run on top. It doesn't always work. And look at the centralized world, a world like AWS. Of course, the applications that run on top of AWS, like Netflix or Apple, are worth more than AWS itself. Okay, so this is something interesting that is solved as well. So these were the 3 observations, and I ran out of time. So thank you, and I hope this made you think.